Imagine for a second, the ground beneath you just suddenly gives way. Not just once, but twice in a matter of moments. Well, on June 24th, the people of Venezuela experienced exactly that. It was one of the country's most terrifying and genuinely powerful natural disasters in over a century. We are talking about a catastrophic event that turned the bustling streets of Caracas into scenes of absolute, unimaginable chaos. Picture swaying skyscrapers, car alarms flashing everywhere, and just immediate, widespread panic. In today's explainer, we're breaking down exactly what happened during this unprecedented disaster. We're going to examine the geological forces at play, the sheer, terrifying speed of the destruction, and the desperate, ongoing race against time to save lives.
Okay, let's dive right into this. Part 1. 40 Seconds of Terror, a Country Shaken. To truly wrap our heads around the magnitude of this disaster, we really have to look at the timeline. I want you to just think about the number 40 for a second. 40. That represents the incredibly brief 40-second window between the two massive tremors that struck northern Venezuela. Take a beat to process how fast that really is. 40 seconds? That is barely enough time to even register that the ground is shaking, let alone find a safe place to take cover, gather your family, or, try to evacuate a whole building. In the context of a major seismic event, having only a 40-second gap means the population was essentially paralyzed. The first quake completely disorients you, and before you can even catch your breath to react, the second one hits.
Which brings us to Part 2, Anatomy of a Doublet, 2 Strikes.
So, to really grasp why this was so absolutely devastating, we need to understand what a doublet earthquake actually is. What exactly hit the Venezuelan coast? Because it definitely wasn't your standard earthquake followed by a bunch of smaller, decaying aftershocks. No, this is a highly rare seismic event where two massive tremors occur in rapid succession. It literally acts like a devastating 1-2 punch delivered by the Earth itself. Normally, in a standard scenario, a big main shock is followed by smaller aftershocks that gradually get weaker and weaker. But in a doublet, the fault line essentially snaps twice. It releases two distinct, massive waves of energy almost back to back. So any structures that are weakened by that first blow are just immediately pulverized by the second. It leaves the infrastructure with absolutely zero resilience.
Let's move to the timeline and see how this builds, because it's terrifying. It starts at exactly 0 seconds. Boom! A massive magnitude 7.2 foreshock violently rocks Yaracuy state. Buildings are immediately stressed to their limits. Then we hit that 40-second mark. It's a terrifying, brief gap in the shaking where people probably thought, okay, the worst is over. But at 41 seconds, the horrifying reality sets in that the first quake was literally just a warning. The massive 7.5 main shock hits. And this ultra-rapid sequence of events is precisely why the destruction was so absolute. There was simply no pause for the Earth, or the people standing on it, to settle.
The sheer escalation of it is hard to overstate. Think about that initial 7.2 foreshock. A 7.2 is already a monster of an earthquake, highly destructive all on its own. But then you compare it to the 7.5 main shock that followed, and notice this absolutely crucial detail. It was shallower. Actually, that's the real kicker here. When an earthquake is shallower, the seismic waves have way less distance to travel through the Earth's crust before hitting the surface. So the shaking felt up at ground level is exponentially more violent. That second punch wasn't just stronger in terms of magnitude, it was delivered right under their feet.
Moving on to Part 3, the San Sebastian Fault, the geological trigger. So what actually caused this massive release of energy? Well, the northern coast of Venezuela basically sits on top of a highly complex and incredibly volatile tectonic boundary. We can break down the mechanics into 3 clear steps. Step 1. Tectonic pressure silently but persistently builds up along the San Sebastian fault line over many, many years. We're talking about 2 immense plates of the Earth's crust locked together, storing up just an unimaginable amount of kinetic energy. Step 2. A sudden violent slip occurs. The rock finally gives way, it fails, and the fault snaps, and in this rare case, it snapped twice. Step 3. Those seismic waves propagate rapidly outward from the fracture, just rushing straight toward densely populated areas. It's a simple 1-2-3 sequence, on paper, sure, but the sheer scale of the energy released is almost incomprehensible until it physically hits the surface.
Let's look at Part 4, the Caracas Soil Amplifier, why high-rises fell.
Now, what's really interesting about the science here, and you might actually be wondering this yourself, if the quake started all the way out in Yaracuy state, why did the capital city of Caracas suffer such profound catastrophic structural failure when it's further away? The answer is a little something called soil amplification. This is a fascinating yet deadly phenomenon where soft ground dramatically increases the intensity and the shaking of seismic waves at the surface. See, Caracas basically sits in a valley that's filled with softer sedimentary soils. When those intense seismic waves from the San Sebastian Fault hit the hard bedrock under Caracas, they didn't just pass evenly through. The moment they entered that soft soil of the valley, the waves slowed down, but their amplitude, meaning the height and sheer violence of the shaking, massively increased. The ground essentially acted like a giant bowl of jelly, magnifying the earthquake's destructive power right directly beneath the city's foundations.
And because of that intense soil amplification, the damage to the infrastructure was absolute. We are talking about entire high-rises literally collapsing in Caracas, completely unable to withstand that magnified back-to-back violent shaking. On top of that, Maiquetía Airport, which is the country's main international gateway, was completely shut down due to severe structural damage. So just think about that. The country's primary connection to the outside world was severed right at the exact moment they needed it the most. It instantly turned what was already a massive rescue operation into a total logistical nightmare.
Which brings us to our final section, Part 5, Race Against Time, the Aftermath. With buildings completely flattened and critical infrastructure crippled, the focus obviously had to shift instantly from understanding the geology to addressing the profound, heartbreaking human cost. I mean, the dust hasn't even settled yet, and emergency responders are dealing with a crisis on a scale this region hasn't seen in generations. We have to look at this staggering number, 235. That is the current confirmed death toll, and tragically, that number is climbing. More than 235 lives have been lost to this doublet earthquake. It is a very somber reminder of the severity behind all the geological data we just talked about. Every single one of those numbers represents a real life, a family, and a community that was completely shattered in just 40 seconds.
So the crucial point right now is how the world is responding to this tragedy in real time. A national state of emergency has been officially declared to help the thousands of injured people across the entire region. To combat that crippled infrastructure we mentioned earlier, international search and rescue teams are flying in as we speak, bringing in highly specialized gear just to dig through the concrete of those collapsed high-rises. And because local communications were completely knocked out, Starlink disaster terminals are actively being deployed to reconnect emergency workers on the ground. It is quite literally a massive race against the clock to pull survivors from the rubble.
As these incredible, desperate rescue efforts continue down in Venezuela, it really forces all of us to take a hard look at our own foundations. We have just seen how a mere 40-second gap, combined with soft soil and an unexpected second shock, can completely cripple a modern, bustling city. Which leaves us with this lingering, pretty unsettling thought. With major fault lines running directly under some of the most densely populated cities all around the globe, are we ever truly prepared for the next doublet earthquake? Thank you so much for exploring this explainer with me today. Keep asking questions, stay curious, and I'll see you next time.